Yeah, hello. Recording start again.
हाँ वाला
Screen and screen दिख रही?
दिख रही है.
Yeah. So welcome, fresher. I am Bharat. Part two. I, along with Utkrist, will be explaining you this problem statement for the Aeronav competition. So I hope you guys are, you guys are working for on that OpenCV assignments and everything, PID controller and everything, because you will be using all of this in solving this. So hope you are understanding it correctly. So let's start with the setting of the problem statement. So what essentially the setting is that there's a military convoy. It is crossing a border road. So while crossing it, they come across an information that enemies have planted various explosive devices ahead of the road. So they have given this task to you to use a drone and count how many number of explosives are there, and then they'll be using that information to defuse them or whatever. So your task is mainly to devise a PID controller for a drone, which you'll program to fly autonomously over the road. Use the camera planted on the drone to get the count that boxes, different colored boxes which are present on the road, and then there are several QR codes situated at the end of the road, which you'll scan and land your drone upon it. I'll be telling you in more detail about this. First, this all this you will be doing in a simulator called Webots. Yeah, so this one, I'll tell you how to download it. Just write Webots in Google, open it. So there's a simple download link for Windows, Ubuntu, Mac, anything. Just, everything is there. You can download this from here and just install it like a regular software. So after doing that, you will get that this window. Also, we have our Git repo. One second. Where is it? Yeah, this one. So this is the Git repo of this competition. So you will be cloning this onto your computer, and in this world folder, you have this world file. This is what you will be opening using Webots. Just click upon it and it will open. So here also we have provided the installation instructions and everything. You can go through this. So after you open this world file, you will be directed here. Here you can see this is the arena. This is the convoy. Here you have your drone. This one, starting platform, road. These are the colored objects. It is a combination of both square boxes and balls. So you here you will write your control. We have provided you with a rough control which will help you get started. So Utresh will be explaining you this further, but yeah, before that, let me explain you here also. So first, what you have to devise a function which will take in two RGB values. We'll be providing you with some colors. We'll just say two colors like red and blue. You have to work with red and blue. So you will provide the RGB values to that function from the terminal, and then only will your drone take off from this platform. It will fly here, go through this road, scan these objects in its path. The relevant boxes, colored boxes, you'll have to count boxes and balls both. So you'll have to count them separately, RGB1 and RGB2. Suppose I give you red and blue. So you'll have to count all the red box and balls and these blue boxes and balls on the way. So you'll go here. The PID control would be devised efficiently so that your drone does not collide with these walls. There's no physics incorporated into these walls. It's just for us to get a feel if your drone is actually going on the path or going outside from it, which has penalties indeed. So try to stay on the road. Your drone will fly over this path here. As soon as you come here, you will have to scan these QR codes again with the camera provided underneath the bot. Let me show you how the camera looks. Yeah, so here you can see the drone flying above. So as soon as the drone goes over here, you have to scan these QR codes, and we have provided you an equation here. Yeah. Yeah, here it is. So you will be using this equation to, you solve this equation, and this value you'll use to that this will be the value of the correct QR code. As soon as you scan it, you will get three values, one single number and an XY coordinate. So you will be using you will land on a drone whose ID matches this particular solution of this equation. You will land upon that QR code using the XY coordinates provided in the QR code, and that would complete your challenge. Yeah, so basically this is the main theme. Let me just go through this if I miss anything. Yeah, so it's all done. Okay, so let me tell you about the rules. So the time limit is 15 minutes, so you have to do it under 15 minutes, and in which we have allowed 3 restarts. If anything happens with a code or something with a laptop or anything, so you will be given 3 restarts. Exceeding this limit will incur penalties, which will disclose the penalties and the marking scheme. Everything will be disclosed later in the event on the date of before the date of submission. So yeah, the drone must also be autonomous all the times. You cannot interrupt it manually or anything. Fly it with your keyboard. Anything. We'll be checking the code. So yeah, don't try that. So it should be autonomous, except when at the start you will input the RGB values. Only then you can use the console. Except that it has to fly autonomously. Also, it has to be directly above the road. As I said, this road, it has to fly over it and not stray from the path. Every time it strays out, there will be a penalty. Also, the height of the drone, at which it should fly, should be not more than 23 meters. It should be below this range. Going above this, again, penalty. And so, yeah, it must not collide with any walls, objects, or the road or anything. So, appropriate points will be deducted for that. Also, the what we have mainly done is that we'll see the efficiency of your code and your approach to solving the problem. You might be thinking that this is pretty simple, but there can be various ways in which you can make your code efficient, and we'd like to see some really great innovations from you. We ourselves have thought about different things which you people can do. So depending on your understanding of the topics, we hope that we find some great solutions from you. So yeah, that will be bonus points.
Yeah, which topic can you say?
What? Yeah,
Which topic?
OpenCV, exactly. OpenCV, PID control, these topics.
Okay.
Yeah. Okay. So this is your bot. This is a DJI Mavic Pro 2. It's a very popular bot. It has been provided with 4 sensors: a GPS, gyro, accelerometer, and a camera. You'll use all this to complete your task. Disqualifications are, obviously plagiarism is very frowned upon here. So don't try to copy from your friend or anything. Manual interruption is also against the rules. And also you cannot modify this. You can modify the placement of these objects here to check if your code is running efficiently. But don't try to modify any roads or these walls or anything. Don't mess up with the measurements of these stuff, and also the positioning of the QR code, because that will get you disqualified. Yeah. So
We
also
any means air drag or friction is there or will not be?
no. The drag and friction, all this stuff is not there in Webots.
Okay.
Hmm. So yeah, also the you try to make a video of your solution. We'll be taking that video as well. Also, I think we'll be doing a live demonstration, in which we'll ask you to come and show your code to us, and we'll give you colors. So yeah, be ready for that too. Also
क्या
now,
करवाएंगे और मुझे नहीं समझ में आता.
क्या क्या hello. Hello. बोलो भाई, कुछ नहीं, ठीक है। So, Utkesh will be explaining you the this control what we have provided you initially, and after that, if you have any confusions or you haven't understood the PS, I'll explain it again to you. So just tell Utkesh.
Yeah. Am I audible?
Yeah.
Sure. So I
So are you going
hope.
to present or you are going to do it on my
Yeah,
screen?
I'm going to present.
Okay. Let's just do it.
So I hope you all get an intuition about what you have to do. If you didn't get it, ask it. Otherwise, you will get messed up what you have to do. Is there any doubt? You could ask, unmute yourself and ask your doubt. So, did everybody understand the problem statement? अरे हाँ ना, कुछ तो बोलो भाई.
Yes, me.
Okay, cool. So let me share my screen. Yeah, so is my screen visible?
Yeah, yeah.
Okay, cool. So here is the file. So first you will have to install Vbot, and then you have to download this code from here. You have to download the zip file. Yeah. So as it is downloaded, you will have to unzip it, and here in the world folder you have the world file which you have to open and get. Yeah. So here you can see here are all the environment setting, like placement of the trees, the trucks, and roads, how they are placed, their position, orientation, etc. So what here we have our drone. It is also here. You can, as you can see, this is the name of our drone, Mavic 2 Pro. So what you have to do, you have to use a controller. So here is your controller. So you can go click here and select, and this is the control that we have given to you. You will use this one, or if you could make your own controller, which is obviously difficult for you, so you can make from here. You can make a new robot controller. Continue, select the language in which you have to make your controller, like we are using Python. Continue, and you have to name your controller anything ABC, and then just a abc.py file will be saved on your controller folder. So you have to, and now if you have to select your controller, you have to click go here and click on this, and now this controller is selected, and now you could start your code here. Here is your ABC controller. So here you have to set put your values of the code or algorithm which you want to apply on your drone. So so let's talk about, you have to work on this controller which we are giving to you. Wait. Yeah, I have selected. So let's start with the code. So here is the library, controller library, from which you have to import the robot, motors, gyro, and everything which you will need to control your robot. Okay. So and here we have imported some more libraries like math, OpenCV, NumPy, etc. Okay. So now let's go here. Yeah, so here is, we have made a drone class of drone. In Vbots we have to initialize our robot. So here we have initialized our robot. We have to initialize our time step, because our time step is very important, because without it you can't do simulation, because time step means clock which sync all the components like camera, gyro, compass, and every other information which are getting. You have to know at which time it is uh, coming, so you can sync all them and use their values together to make your robot work perfectly. So now here we have initialized our camera and we have to enable it using this function, and like this we have initialized all the other things, and we have used here we have used IMU unit, GPS, compass, gyroscope. Here you don't need this because we have said you can't change the camera roll pitch motor because it is already facing downward, so you don't need them, and you don't need this information of propellers too. So we and now here, yeah, so we have made a function move which you will use to move your drone. Okay, I will explain you how this function work, and then here are some PIDs value gains we have set it to make our drone stable. And here we have took the camera image array from the camera, and we have applied some function which are required. And then so now what you have to do starts from here. You We have make a object of the class drone. So how your code work? So if you want to move your drone up, okay, means you have to increase the altitude of your drone. So there are four operation which you can do on a drone. You can throttle it, you can pitch it, roll it, and yaw it. So uh, let's talk about throttling, that is moving up, increasing its altitude. So always remember in this control, as I have, if you could see in the code, as I have uh, applied the drone dot move function, and if you have to go up, you simply just uh, type up in pass a string and just give the intensity. And how you will give the intensity of throttling means altitude? If you could see here we have took 100 iterations, means after 100 iteration moving up process will be stopped. And if you give, like I am giving zero point 0.1 for up, so it will add on the altitude, means 100 into 1.1, it means I have to increase my altitude by 10 meters. Okay, so if you could see, if I give this 0 intensity 0, it will not go forward. Command is okay. And let's check. So yeah, so it will just move up and stabilize on 10 plus 1, because 1 is the offset value which is required. As you can see here, the z-axis you have got the 10.89, which will just oscillate on approx on the value of height approx 11. Okay, so now if you have to move forward like this, you have to just give the forward and give the intensity in which you have to make it move. For example, one you have given one, and save it and just run the code. So it will height up for 100 iteration, and then it will start moving forward. Wait, I guess it is not saved, code is not saved. Wait, 5, yeah. Yeah, as you can see this drone is going forward. Yeah, so this is how you will and for uh, pitch, for example, you have to pitch it rightward. You have to use this command, s right, for pitching your drone. For example, it oh, Yeah, as you can see here, our drone is pitching rightwards. So by using this, you can control your drone. Or one more thing for yaw, you have to use this only right. You can see it from here as here. Uh, Here forward, backward, right, left. S right means roll, S left means roll. On rightwards, leftward. Up means increasing the altitude, down means decreasing the altitude. I hope you get this. And the last thing is this, how you will use the drone sensors. So if you have to get the roll or pitch or yaw angles of a drone, so you will simply Mm, write drone.imu dot roll pitch yaw. Okay, so it will return a array of row, which will contain, first will contain roll, the second thing will contain pitch, and the third will contain yaw. So as you can see, it will start printing on here console. So here are the roll pitch yaw angles. As you can see, this is crashed because we didn't give the move function. After 100 iteration, the drone will be stabilized, but then the move function is not working. So always, if you are in any loop, you are not using the move function, it will crash. So always you have to use the uh, drone dot move, and up. And if you didn't have to increase anything, you just simply give 0 value, so that it will be stable, it will not go down, not fall off. Okay, so as you can see, uh, here it is giving the roll pitch yaw values, this roll pitch yaw. And for its GPS value, you will be using this command, mm, gps dot get values. So this will give you the values of its coordinate, xyz coordinate. So here it is. uh, as you can see, as this drone gets up, the z axis increases. It is increasing 5 6 7 like this. Yeah, and the next thing is uh, camera image. So as a drone already takes too much control input, so the process is slow. So you can't iterate on every loop. You can't get the image and on every loop and print it, matlab show like this. For taking image, you can print drone dot get image. It will give you the image array, and then you can use OpenCV. I have used it will show your image after 100 iteration. So as you can see here, uh, it, here the image is coming after 100 time steps. So this is feasible, because if you took wait, if you took your image on every loop, so there is a problem that your simulation will run very slowly. See, the simulation is running too slowly. Its running speed is 0.08x. So that's why we use this thing. So you could take the image, and you could operate all the functions which are needed, and then you, according to that, you have to plan the path and make it travel through the whole arena. And now here, when you come here, you have to scan the QR codes, and QR codes will be having three values. All QR codes will be having three values, which whose IDs will match the function which we have given to you. You have to land on that QR code. So this is how you could do. And for doubts which you will face while solving, you could ask your mentors. Mentors will be allotted to you all.
So yeah,
So, and yeah.
that you said that yeah, we cannot take the image at every loop. So In that means after every 100 loops it will take an image. Is it like that?
Yeah, yeah, yeah.
Okay, then in means in between that, if it get if any image is missed, then
No, 100 is a very small number, 100 is a very small number. You won't miss any image. Like if you see here, wait, let me show you. Here is the viewability screen. You will not, if you think you are missing some images, you can just simply change the value. Here you can change the value to 50 or 0, but it will make your codes very slow, so keep that in mind.
okay, means that in that loop we have to according to the loop it will rise up, then it will move forward, and at the time of turning, at the time of pitch it will pitch. It will be according to the loop exactly.
Yeah, yeah, you have to code, मतलब you have to give if else condition. Like for example कि तुम्हारा drone, like here is it is the 35 0 coordinate of this. So you know that after here your drone will have to turn, so you have to give the if condition. If the GPS की जो x value है is greater than 35, start rolling या pitching या yaw, which you have to hit and tell and check that.
And via that forward s right, these are functions that you have created in this code.
Yeah, yeah,
These are
yeah,
not
you have.
inbuilt.
No, I have created this class so that it is easy for you. You should not have to worry about the speed of the propeller. You should simply just give S right for rolling right, S left for rolling left, forward for pitching forward, or backward for pitching backward, and for right and left you will be yawing. I guess I didn't show you how the yaw code. So this is how, yeah, as you can see, your drone is yawing, rotating on its own axis. You get it? Hello? Is your doubt clear?
Yes, भैया, yes.
Okay, cool. Any other doubts?
You said that there'll be 15 minutes to complete the assignment.
Yeah.
Yeah, so what does that mean? Does that mean like after this workshop is over, 15
None,
minutes?
none,
No,
none. The
like
simulation.
when we yes, when we call you for the submissions, we see the live presentation, or when you run the simulation, then it must be less than 15 minutes. You know, to your you should when the simulation runs, your drone must take less than 15 minutes to reach that QR code and land upon it. You are getting at 5 days to complete this assignment. So that's what's the date today? 9. So yeah, 5 days from now, 14th, 14th.
Oh, so it doesn't include the coding time.
Yeah, what?
The 15 minutes doesn't include the development time, the coding time.
No, no,
No.
no, no. Like
Okay.
Where you said like we should take their 100. If someone takes their 50 and his computer programming is very fast, then it would be very, it doesn't matter, right?
Actually, there are two times: simulation time and real time. So simulation time is same for everyone. Real time may changes, but simulation time is same for everyone, so we will be evaluating on that behalf.
भैया सिमुलेशन टाइम कैसे पता चलता है, वो मैं भी सोच रहा था। मीन्स हाउ द सिमुलेशन टाइम इज नोन?
Okay, as you can see here,
सॉरी सॉरी सॉरी, रियल टाइम।
रियल टाइम इज़ आर नॉर्मल टाइम। मतलब मैंने सिमुलेशन स्टार्ट किया और अभी से क्लॉक में मेरे 3 मिनट बाद ये ख़त्म हुआ, बट
Okay.
यहाँ पे इधर पे स्लो रन कर रहा है, तो जो यहाँ पे रन होगा तो वो मतलब 2 मिनट का ही दिखाएगा 3 मिनट में, समझ गए ना। यहाँ पे स्पीड यहाँ
Okay.
पे अगर 1x से कम है तो वो
Okay, that X is about that.
या
Okay.
ये दोबारा बता दीजिए, समझ नहीं आया।
या सो जैसे कि मैंने यहाँ फास्ट फॉरवर्ड किया है, ठीक है। तो यहाँ पे अगर तुम फास्ट फॉरवर्ड में देखोगे, यहाँ पे 1.3 और 8 ये कंप्यूटेशन टाइम होता है जो हमारा प्रोसेसर लेता है कंप्यूट करने के लिए वैल्यूज़ या जो भी, तो उसमें ये टाइम वेरी करता रहता है। तो इस जैसे कि अभी हमारा क्लॉक, अगर तुम सिमुलेशन देख रहे हो और हमारा यहाँ पे 38 पे स्टार्ट किया है और हमारा पूरा सिमुलेशन ख़त्म हुआ है 40 पे, मतलब 2 मिनट्स हमको अपनी क्लॉक के हिसाब से लगे, रियल टाइम के हिसाब से लगे। बट अगर सिमुलेशन में देखोगे, अगर हमारा सिमुलेशन कंप्यूटर की प्रोसेसिंग स्पीड स्लो है तो वो कम रहेगा, मतलब 1 मिनट आएगा यहाँ पे, ठीक है। और अगर हमारी सिमुलेशन स्पीड ज़्यादा है, कंप्यूटर की कंप्यूटेशन स्पीड ज़्यादा है, तो वही काम फास्ट हो जाएगा। तो मे बी वो 3-4 मिनट्स का काम वो तुमको 2 मिनट में करके दिखा देगा। तो यहाँ पे जो सिमुलेशन टाइम होता है इसके बिहाफ पे हम लोग चेक करेंगे, ये सबका सेम होगा।
सो कोई और डाउट? PS समझ में आ गया ना सबको?
Yes.
कोई कोई ऐसा जिसको ना आया हो?
भैया इसमें रिक्वायरमेंट क्या होनी चाहिए, मतलब रैम और मेमोरी के साथ?
तुम अभी अपने करंट पे चलाओ, लाइक उसने बोला मतलब अभी बोला ना कि लाइक सिमुलेशन टाइम पे हम जज करेंगे, तो वो तुम लोग का सेम हिसाब से आएगा। तुम हो सकता है कि तुम्हारा मतलब कंप्यूटर थोड़ा बैक एंड हो, थोड़ा तुमको टाइम लगेगा कि सिमुलेशन कंप्लीट होने में, थोड़ा अपने वो चेक करने में कि कितनी देर में मतलब मेरा सोल्यूशन कैसा है, लाइक कैसे वर्क कर रहा है एंड में। ये सब में भी तुमको टाइम लगे कि अपना अपना सोल्यूशन देखने के लिए अपनी स्क्रीन पे। बट जो तुम्हारा एक्चुअल हम जिससे तुम्हारा इवेल्युएशन करेंगे वो सेम रहेगा सबके लिए।
ओके भैया।
या कोई और डाउट? कोई भी?
भैया ये जो Webots है, it is not a library of Python, है ना?
ये एक सिमुलेटर है, एक सिमुलेशन सॉफ्टवेयर है वीबॉट्स।
और भैया
सिमुलेटर तो
पाई
तुम
बुलेट
लोगों को
भी तो
पता है।
एक सिमुलेटर है।
हाँ, पाइबुलेट भी सिमुलेटर है।
एक्चुअली पाई बुलेट
लेकिन वो तो
सिमुलेटर नहीं है, पाई बुलेट लाइब्रेरी है और बुलेट इज़ द सिमुलेटर।
या मतलब हाँ, लाइक यूजिंग पाइथन इन बुलेट इज पाइबुलेट।
लेकिन वो तो पाइथन का लाइब्रेरी जैसे हम इंपोर्ट करते हैं ना, numpy जैसे या ओपन
या वो
सी जैसे।
डिफरेंट है, ये ऐसे इंपोर्ट नहीं होता है, इसको प्रॉपर इंस्टॉल करना पड़ता है।
ओके, लेकिन जो कोड रहेगा वो तो सिर्फ मतलब पाइथन या जो भी सी जिसमें
हाँ।
होगा वो ही लिखेंगे ना।
हम्म।
मतलब भैया इसमें सिर्फ मतलब पाइथन और ये जो ओपन सीवी और ये पाइथन का अंडरस्टैंडिंग चाहिए बस।
या और
हाँ,
पीआईडी।
और पीआईडी, यस।
मतलब और अगर तुम लोग कुछ एक्स्ट्रा करते हो, जैसे कि हमारा जो रोड है, अगर तुम मे बी तुम लोग को हमने कोऑर्डिनेट्स बता दिए हैं, तो मे बी तुम लोग उन कोऑर्डिनेट्स के अकॉर्डिंग अपने ड्रोन को हार्ड कोड करके उसके थ्रू ट्रैवल करा सकते हो। बट अगर तुम लोग रोड डिटेक्ट करके ओपन सीवी या कोई भी एल्गोरिथम लगा के मतलब जो लाइन है, वाइट वाली लाइन होती है बीच में, उसको डिटेक्ट करके अपने ड्रोन को फॉलो करवा रहे हो, तो ऐसी कुछ भी स्पेशल एल्गोरिथम लिख रहे हो तो वो भी मेंशन कर देना सबमिशन के टाइम में, उसके भी बोनस पॉइंट्स रहेंगे।
भैया और नंबर ऑफ कोड लाइंस उससे इफेक्ट पड़ेगा कुछ?
नहीं नहीं नहीं,
नहीं भाई,
मतलब
उससे कहाँ फर्क पड़ेगा। बस तुम्हारी एफिशिएंसी देखी जाएगी। लाइक एक्चुअली उसमें अगर कोड नंबर ऑफ कोड लाइंस भी इम्पोर्टेंस रख रहा है तो ऑब्वियसली हम उस पर ध्यान देंगे, बट इन द एंड इट्स ऑल अबाउट बीइंग मेकिंग इट एफिशिएंट।
और मेन बात ये भी है कि जैसे कि अगर तुम रोड डिटेक्ट करते हो तो वो थोड़ा सा टाइम ज़्यादा कंज्यूम करता है, बट दैट इज़ एन गुड वे फॉर सॉल्विंग अ प्रॉब्लम, so we will give extra marks for that.
What if everything is covered, we can shut down the recordings.
या भैया हाँ।